Okay, let me share my screen. Okay. Yeah, are you able to see my screen now? Something is happening. I'm not able to record it or start the. Just a minute. No, no, no. Yeah, I think now we got it back. Are you able to see the screen? Yeah, yeah. That's something happened. Okay. So, okay. So, I mean, so far this is good. So we have a two-tier architecture. But what is drawback with this two-tier architecture? The drawback with this two-tier architecture is basically like you are not able to scale it up. I mean to say, for example, we have one server. It can access or it can serve 1,000 customers at a time. For example, we have taken simple that results application, right? Maybe an MSET or 10th board or 12th board exams, you will simply enter and you'll get the marks. So that could able to serve 1,000 requests per minute. But it would be so busy on that day that there would be millions of people trying to access this site through various browsers, right? That's possible, right? Generally, on the results day when it is announced, everybody wants to see that. So how do we do that? If your machine is capable of handling only 1,000 requests per minute, and if you want to do it on a large scale, on millions of users per minute, you cannot do that with the present. So what we need to do? So what we need to do, we need to create another server. Okay, so there would be some load balancing sort of a thing. So client sends a request. Okay, so one request would be sent to this and the second request would be sent to this, right? In similarly, you can have another server. One request would be, so it would be like we are sharing the load, right? One application cannot do that, but multiple applications at the same time can do that. So some we need some mechanism, something that basically helps you to the share that load among all the servers. This is, you can have n number of servers on that day. You can deploy the same logic and same database on the have some 100 servers, and you can have this load balancing done at this place. So everybody shares load, you can do that. That is possible. Even with the two-tier architecture, you can achieve that. But when this data that we are accessing is just only for a read-only purpose. For example, in the results, right, you have declared result, everything is data is done, the database would be replicated everywhere. There won't be any change in the database everywhere. The same database, you can place it in every application, right? In such scenarios, it works. So with the even the two-tier architecture, you can have hundreds of machines and you can do this load balancing, and you can achieve that when your database is just a read-only database, something like a Wikipedia, right? So a Wikipedia, there would be a million hits every minute across the world. How it would able to access it? How would it able to serve it? It's a simple thing. It has hundreds of servers, you know, in each and every geographic location. In US, it would have, for each state it would have one server. In India, in it would have around 5 or 6 servers, one in Hyderabad, one in Bangalore, one in some other city, in Mumbai, in Delhi, in Kolkata. So it's like you can have multiple instances of the same database, the same read-only database, which does not have much of changes in it, or which will not get much of the changes in it. So everybody can simply access it. So that's like a read-only operations. Imagine you have to do or you have to provide something like a banking application. So the database here, it is like a banking application. Sorry. Okay, forget about it. So a banking application. So there is a bank and hundreds. Earlier we used to have hundreds of users. So this client server application would work. But now we have, yeah, millions of users they would do. Now we got a UPI. You have multiple other options to interact with bank. There would be a millions or billions of transactions coming uh, per day. Can you have or can you use this type of model? We cannot use, because here we have multiple databases, right? This is DB1, DB2 replica 2, this is replica 3, and this is replica 4. So what would happen? For example, in one, the user connected sent a withdrawal of 1,000 rupees from some X account. X has earlier 2,000. It is only now we have a request for 1,000. So X now has only 1,000, right? That is reflected only here. In all the other databases, the X would be 2,000. X will have 2,000 balance in their account. If some other request sent to withdraw 2,000 from the user to the application, and if that is routed to this, it would simply go through. It would clear the transaction, and 2,000 rupees would be deducted from this account. So here it becomes zero. But actually, he is eligible to withdraw only 1,000 after the first transaction. It's not possible here. It should not be possible. It should have thrown an error, but it has cleared the transaction. Why? Because there is no sync between these DBs. Why? Because we have created application server, multiple application servers which has database in it them. So they have their own database copy, and there is no mechanism to sync these two. So in such scenario, How do we avoid that? This is the drawback of the two-tier architecture. What is the drawback? If anybody can explain, like if you understood. Yeah, like in the two tier, we would have basically the logic and the database both are in the same place, and you have multiple applications connecting to it, and the single application is connecting to the single database, and multiple users is connecting to it. So in this scenario, there you cannot have a synchronization between the multiple instances. So this is one instance, this is two instance. So there won't be any sync between these application servers. When it is a transactional data, you cannot or the two-tier application cannot provide the what we can say the integrity of the operations. So because of these scenarios, because of these drawbacks, to overcome these drawbacks, we have something called as a entire architecture. You can call them as three tier, even two tier is also, we can call them as an entire architecture, but generally we don't call it. So three tier, you can have four tiers, you can have five tiers, but it's basically about again what we are doing here. Previously we have reduced or removed the presentation logic from the application, because you'll have multiple users, and each user, you if you want to allow we want to allow each user to access them separately. We have what we can say, like bifurcated this entire application, and we have presented this presentation layer as a separate layer, and business and data store are in a single layer. Now what we are doing, the next step is like we are dividing this also. The business logic stays in one area and the data access stays in another area, right? So here you'll have a single database server. You can have n number of application servers. You can have single database server, you can hundreds of application servers, and you can have thousands of client computers, right? So the web application, what we have previously, we have right, there would be one load balancer here between the clients. There would be a load balancer. So the clients would send the requests, it would choose the application server. For example, in case of banking application, you have hundreds of servers, or you can have tens of servers, right? So from the client application, it can pick any of the server. It can pick any of the server. The basic core application logic only will be there in the application server. The data would be stored in some other server that's called as a database server. All these application servers would connect to the single database. Okay, it's just a data store. The basic processing, everything happens here. Only these things would fetch the data from here and update the data from in this data store. Right? This is how an entire application. So what we are basically doing in a layered architecture is like we are basically separating the concerns. Right? What are the concerns? How do you store data in a database? How do you maintain data? That is basically one, or we can call that as a persistence. How do you persist the data and how do you maintain the data is at one tier, that is completely separated. And the client tier, how do you present the data? How do you allow the user to request the data? What interface you would provide? This is basically at the client tier, that is a separate tier. And how do you process the data is basically a separate layer. So these three concerns, right? Input, process, and store. These three concerns are separated into three layers. It could be 4 layers also in further, but I'm generally saying. So that's why it's called as a 3-tier architecture. So what it does, it basically divides all the layers. It's a separate application and it runs on a separate computer. It's a separate application. The client application runs, it could be a simple web browser or a internet explorer on which you will basically get the data, and the business logic tier would basically executes core business logic. A simple thing, right? If you want to withdraw an amount, you have 2000, but there is a request came to withdraw 5000. What is the business logic here? You need to check what is the available balance. Once the balance available is more than the amount, then you will go through it. If it is less than, then you'll throw an exception or you'll throw an error, right? So this is all business logic happens here. Once the operation is done, you have to store the end result in a database, right? So initially he has 2000 rupees. Now we have requested 5000. We have rejected it. We need not store anything here. Next he requested for withdrawing 1000 rupees. So we have to store it here. It would become 1000 rupees. And then he deposited around 4000. So we have to again store it here. It would become 5000. So the data store happens here. You understood, right? Why we are doing this, or why the need to have an entire architecture is came into the place. Okay, so what is the advantage of this? So we have designed a system that works for million transactions per minute, right? We have designed a system so you can have million client computers or million browsers can send a request at the same time. Here you'll have some here you'll have some 100 application servers which will be load balanced, and those application servers can connect to the database server and pick the data and send it. The scalability, we are scaling up our application to, at the same time we are also providing the consistency of data in the data. The data consistency is there. How many of you know about ACID transactions? Have you ever heard about ACID? Nidun, I'm expecting answer from you. Okay, let me just, I don't want to get into it deeply, but ACID basically stands for atomicity, consistency, integration, and durability. That means it's basically related to a database transaction. When you have done some transaction on the database, it should be stored permanently. That is called as a durable, right? Atomicity, either the transaction is completed. I mean to say, for example, we have send a request to transfer amount from X account to Y account. This is the transaction. So this transaction atomicity means either it should be completed at whole or rejected at whole. You cannot have half the transaction, right? For example, in the transfer, we need to do two transactions. One is withdraw from X, withdrawal from X, and two is deposit at Y. Deposit at Y. These two transactions, the two actions are called as a single transaction. So the ACID property is what it basically ensures that either both are done. For example, if there is 1000 rupees you are transferring from X to Y, the 1000 should be withdrawn at X and that should be deposited at Y. If any of the transaction fails, both transactions should be rolled back. right? Otherwise, what will happen? You don't have consistency in your data. So earlier he has 2000 rupees, now he has only 1000. Where the other 1000 gone? Imagine if it is failed. If it is failed, it could be 100 reasons to fail that transaction. So where the 1000 is gone? So then what you need to do, the earlier transaction that we have done withdrawing should be cancelled. So then what will happen? You'll have 2000. There is no change, right? So those such to achieve these asset properties, to maintain the data consistency and to improve the performance or scalability, we can use the three-tier architecture. The three-tier architecture allows you to achieve all these things, no, in an distributed environment, right? There are many applications, like the most of applications till now we have are in this architecture only, the entire architecture or the distributed architecture, right? From, if you see railway reservation and banking portals, various other applications, almost around 80% of the applications runs on this entire architecture. Why did I say entire instead of three tier? Because again, right, in business logic tier, whatever we're calling it, it can again be divided into multiple layers. So that's why they call it as an entire architecture. Clear? Any doubts? Yeah, thank you. Thank you, Ravi. So, we have discussed about two tier and three tier in the layered architecture, right? And there are various improved variations in the layered architecture. So, one is like what we have seen just now, the layered architecture. So, separation of concerns, presentation layer, business layer, and the database layer. But there is a disadvantage with this. It's basically like a tightly coupled. What is tightly coupled in the sense is like, these layers are dependent on each other, right? Like the presentation layer, the business layer, the database layer, they are dependent on each other. The business layer should know what database we are using, right? So how to interact with the database. Similarly, the client tier should know about the business logic, business tier and applications. So that tight coupling is there in the layered architecture. So again, there is another improved version called as an hexagonal architecture. So it's basically to reduce that coupling in the business logic. It has concept of ports and adapters. I would explain, and you'll have some external dependencies of the hexagonal architecture. It's again, right, in the layered, whatever the shortcoming in the layered architecture is one of the like tight coupling. To address that, we have this concept of decoupling the business logic using something called as a hexagonal architecture, right? From hexagonal architecture, again you have something called as an onion architecture. So what is an onion architecture? In onion architecture, again you have layers like how an onion would have, right? Within the business logic, within the business layer, again you'll have various layers. We will see how it would basically go through. I mean, how it is would be restructured. From onion again, there would be some rigidity in the onion architecture. Then we got the clean architecture, right? It is more simple than an onion architecture. Uh, onion architecture actually, I mean, supposed to be one of the best architectures, but for few of the scenarios, and few scenarios it becomes a rigid because of the business layers we have. It becomes too complex. So then we got the clean architecture, like it simplifies the onion architecture a bit more. So we'll see how it's going to be. So we'll go with the hexagonal. Yeah. So as we say, this is, I mean, earlier also we have seen it, right? So in this application, this is the total application. So we have again 3 layers. This is common. I mean, this is the presentation layer basically, or the user interface layer. We don't call it as a presentation layer, it's a user interface layer, right? Here you'll have data access and other external services. And this is your core application logic. This is similar like a layered architecture, but there are some additional variations. It's basically the application logic, it basically provides some services, and user interface could be anything. It could be a simple web browser, it could be an API, it could be a command line interface, it could be some X, it could be a web service, it could be some other X. Here we are decoupling the presentation layer to the business layer. It could be anything. In presentation layer you can have anything. It does not make any sense to the application core. Application core logic will not depend on, or will not bother what user interface it is calling. The core application logic would remain same. What is the need for this? For example, we said, right, we have a banking application. Earlier we used to have a banking application at the banks only. If you want to do anything, you have to go to bank. Then came ATMs, right? We got ATM. ATM is a new interface. Okay. And after that, we got websites, banking sites, web banking. Okay. And after that, we got mobile banking or smartphone banking. And after that, we got UPIs. Right. The way we interact with the core banking application changes every time. But every time we should not change this. The core application logic remains the same. If you want to have an additional, okay, we have ATM and web. By now we want to have phone banking. We want to create an Android app. Create. There is another new that could directly use the same core application services. In future, you got something called as a UPI. Create and connect. So this is called as, the business application or the business logic is decoupled from the type of interfaces you are using. Similarly, at the second and or the secondary, and you have data access. Today it could be some Oracle RDBMS, tomorrow it could be something else. It needs to be decoupled. And you can use any email service. Today you're using some Gmail service, you can use some other service. You need to decouple it, right? Future In future you want to have something like a WhatsApp, you can have. So the business logic, what we are doing in here, should not change or should not be affected by the external things. The data access is an external store, the email service, the SMS service, the interfaces, APIs, these are all external to your core business logic. So the hexagonal architecture is something like you have a core business logic, it provides services, it doesn't care or doesn't bother about who is going to interact with him and what data they need and how they is going to request and how I'm going to store the data. So for all these things, it internally maintains a standard set of services. Those services, whatever the secondary services or primary external services we have, they basically have to interact our core application using the provided services. So that is the responsibility of these services, not the core banking application. That is what a hexagonal architecture is. You got any doubts on this? Hello? Hello, am I audible? Yes. Yeah. So, the core principle behind this architecture is like, here we have something called as a ports and adapters, right? What is a port? So here in this, for example, in a banking application, there would be a port created. The port is nothing but a service to withdraw the application, withdraw the amount. Another port is created for depositing money. Another port is created for transferring the money. Another port is created for some other X operation. So the ports are created, right? So the applications would basically interact to that port. The port internally runs or the application core logic, whatever it is done. So it is not disturbed by any changes in the interfaces. That is what an hexagonal architecture is about. So what is the advantage of it is, it's like it's a loose coupling. We call that as a loose coupling. So whatever we have earlier, the same presentation layer, but there would be a direct interaction between the presentation layer and the application logic. Now we don't have a direct interaction. We would done through something called as a ports and adapters. It's also called as a ports and adapters pattern, but it's also named as hexagonal. Okay, it's a variation in a layered architecture. All right, and okay, I'm speeding up. I think we already have 1 o'clock. Similarly, yeah. Yeah, for me it's okay. Yeah, I think we will try to wrap it up, and otherwise we will try to cover it in the next any other sessions. We will at least they'll have the layered architecture part. Yeah. So yeah, when it comes to the onion architecture, the all whatever I have explained in the hexagonal would apply to the onion architecture. The only difference is how you have internally maintained the application core logic. Here you will have layers. The central layer is called as a domain layer, right? So this domain, you'll have a business domain model or the business rules at the center of your application core logic. On top of that, you will have various services, right? For example, what is a domain model? In a banking application, you have an account. Bank account is a domain model. Account object is a model, right? And what are all the applications or what are all the properties that banking account would have, what are all the operations that we can perform on that, everything is mentioned here in the domain model. To simply say, all the entities would be part of this domain model, all the business rules would be part of the domain model, right? On top of that, you'll have the application services and infrastructure services, and these are multiple layers. You cannot directly interact with the domain model. You have to come to this, and that this would basically connect to this one, and this would basically connect to this one. To simply say, to simply explain, you have a bank account object. How do you access to the bank account object? You have something called as a repository. I'm not going into the deep. That would again this one it would confuse, and we also don't have much of time. So it's basically like the basic, all the database entities would be part of your domain model, or the simply to tell you, all the database tables, we can call them as, would be part of your domain model. This is basically at the center of your application. And how do you access, how do you manipulate for that? Okay, how do you manipulate that? This is all basically the services part, right? So you have domain model, bank account. What would be the services? The account would allow you to deposit, withdraw, transfer, XYZ operations. These are all services. Okay. On top of that, you have infrastructure. What is infrastructure? Once you have performed the operation, or what we have called the ports and adapters, right, in the previous, that would basically be and in this infrastructure. So through user interface, you'll connect to the port. That port would basically connect to a service. That service would basically connect to the domain model. Again, you want to store the data. There would be a service to save the account or deposit the account. Whatever we have deposited, that needs to be saved, right? That would again will have a port which connects you to the database, or retrieve from the database will be done through this port. But this port directly cannot access the domain model. It has to go through only a service layer. So it's basically the domain model. You'll have a service layer. On top of that, you'll have some infrastructure layer, what we call it as in the onion architecture. Sometimes it's also called as a repository layer in case of a data access scenario. So this is how, whatever we have explained, all these things would apply to the onion architecture. The only difference between onion architecture and hexagonal architecture is like in the onion architecture, the application core logic is again divided into multiple layers, right? So earlier we have only presentation layer, data access layer, and the business layer. In the business layer, again you have multiple layers. That's how the difference between onion layer and hexagonal layer. So here, one more advantage with this is like, for example, here we are changing a port, right? What happens? Port is basically has some core logic that would get disturbed if you are trying to change the port, right? In this scenario, we are simply decoupling that again. Within the business logic, the changes in outer layers dependent on inner layers, but sorry, the change in outer layer will not impact the inner layer. But if there is any change in inner layer, that would basically impact the outer layers, right? So the dependency is in this way. You need not. Okay, I think again I need to go for the dependency inversion principle. Uh, Okay, just imagine. I mean, I'm not going into again the dependency inversion itself is a separate topic that takes around 1 or 2 hours. So I'm not going into that. So the only the difference between hexagonal and onion is like uh, in hexagonal the business application core logic is not structured or in onion architecture it is structured in a layered way where the dependency starts from outer layer to inner layer, not the vice versa. So this inner layer, if you change anything here, it would change, but any change here will not impact the inner layer. That's a simple principle. So the flexibility is like changes to UI or external systems don't affect the business logic. Similarly, I think, okay. Any doubts on this? Hello. Okay, let's move to the next layered architecture. Um, the next one is a clean architecture. As I said, right, in this initially, onion is basically it becomes complex and rigid because of the restriction of the layers that follow. So it may not be suitable for all sorts of applications. So then they came with something called as a clean architecture. It is similar to the onion architecture. You have a domain model. You have a domain model at the core, and on top of that you will have application model. On top of that you will have a web UI model. Okay, but the thing is like there is no strict implementation of you should go only layer by layer. Sometimes from the infrastructure layer you can connect to the domain, right? So you can do that. So it's not as rigid as the onion model. So there are some additional or flexibilities provided. uh, that is a basic difference between a clean architecture and an onion architecture. So clean architecture has like it has all the I mean good things or all the things of the onion architecture, but the thing is like you can tweak it as per your convenience. Any doubts on this, or can we move ahead? Ravi, yeah, like what can we do? Like, should I continue? Okay. Okay. Yeah. Yeah. I mean, what is the? I mean, we have gone through the layered architectures, right? The layered architectures hexagonal, clean, onion architectures and all. So these are all good, but the problem is like, you have one application, the core business application that we are talking, right? This is the core business application. It over the time it becomes too heavy. It becomes a big, monstrous monolithic application, right? Even though we have various layers in that, again it becomes a big application which is basically hard to maintain. The entire thing becomes a very big application with thousands of classes and thousands of lines of code. It becomes a big application. If you just make any simple change, you need to do again rebuild the entire application and check that. So to avoid that such a scenario, because of that, what happens? You need so many resources and everything. So what we came up with is like, divide your large business layer, or what we can say the application layer, right? Application core logic, this into multiple applications. There is something called as an account service, a book service, order service, shipping service. You have multiple services. Earlier, all these four used to be part of one single monolithic application. Now what we have done, we have divided them into four. 1, 2, 3 and 4. So all will be deployed separately. They need not be deployed in a single machine. This can be deployed in X machine, it can be deployed in another Y machine, and there would be something called as an enterprise service bus, which basically connects all these services, right? The customer, for example, to simply say, you want to open one, or you applied for a telephone connection. Imagine that's a simple thing. So in the scenario, for example, you have applied, or in an e-commerce application, you have ordered something in an Amazon, right? What initially you need to do, you have to select some item and you have to book that item, add that to the shopping cart, and then order that. Once you have ordered that, it needs to be shipped, right? So all this core logic, earlier there is only one application. The scalability is tough. What we are doing here, we have divided them into multiple applications, right? So when the customer one comes, we will display a list of options. He'll select something. The book service would basically interacted. I mean, you'll send a request to the enterprise service bus. You'll send a message that I want to book some XYZ item. So that would be taken by the book service. The book service would create that, or completes the booking and sends a message, booking is done, can you complete the payment? He creates a message to send a payment that would be consumed by this order service. Once the payment is done, the order service confirms that payment and then says order is confirmed. It again go to this one, or order is confirmed, please ship it to, please perform, or please process the shipping to the shipping service. The shipping service would basically perform some operation and send it the shipping details to the user. So this is entire a single application, but what we are doing, previously it is used to be part of the same application. The user used to connect to the single, right? So 3 user interfaces through API used to connect to this, and it come back again connect to this and come back. It's a single application doing the things. But in the service oriented architecture, your application is divided into multiple services. These are loosely, there is no connection, direct connection between them. They can work independently. They don't wait for they don't need the other services to perform their part of job. Booking service will do booking only. Order service will do order confirmation and order verification. Shipping service will do only shipping, right? So they will do their independent jobs without depending on the others. And how do they interact with? They'll interact through messages. Earlier we used to have SOAP messages. Using SOAP messages, we used to communicate between the user and the various other applications. Or the user means the presentation layer and the various other applications or various other services. So what is the advantage of this? Each service runs in a separate machine. Each service runs better. For example, account service like many less number of users will access the account service, but many users will use the book service. So you can have multiple instances where book service is running, multiple servers where book service. You can have 100 servers running the book service, but only 10 running the account service, right? Because here for this traffic is more. So multiple book services would cater to the user requests efficiently, right? If it is the same case, what we need to do here, this big monolithic application, we have to deploy this big monolithic application in all the 100 servers. You need higher capacity servers, but here you don't need that much of higher capacity servers in an SOA architecture. So this is good, but it is a problem. The problem is like this enterprise service bus could be a bottleneck. Do you know what is a bottleneck? Enterprise service bus is nothing but a message broker. When you have hundreds of services accessing the application through a single message broker, there is a chance that this message broker get clogged. So there would be millions of messages coming in, and the services are not able to process all of them so that would basically it has a capacity to hold around a million messages at any time. When it crosses the threshold, what will happen to those messages? So these problems would come in a service oriented architecture. So to avoid that or to overcome that, we came up with a microservices architecture. The difference between microservices and service oriented architecture is simply explained in this. Monolithic is a single big box. We have divided that single big blocks into multiple services, small boxes. Okay. That again fine grind into smaller services, that's called as a microservices. And these microservices are generally, you can use the enterprise service bus, but generally they interact with services using various brokers, not a single message or single service bus. That is the only difference between a service oriented architecture and a microservice. They can interact with the other services directly, right? Book service and order service. Earlier, what they used to do, they used to talk through the enterprise service bus. They can also, in microservices, they can also interact with each other directly, or you can have a concept of various small service buses between the microservices. So that's the difference between service oriented architecture and microservices. Another is like we have a new concept called JSON and REST. So you can use REST, you can use GraphQL, you can use gRPC, various mechanisms to interact between the microservices. You can use all of them. It's more scalable, more flexible, and resilient architecture when compared to the SOA. Where SOA is more scalable, more resilient, and um, uh, flexible architecture when compared to monolith, right? So similarly, the microservices would work, but the difference is like at a smaller scale. So here you may have entire booking service as a single one. Here you can again that booking service you can have a shopping cart service. You can have recommendation service. You can have some XYZ service like that. An additional part. More fine grained services here. Okay. Yeah, yeah, yeah. No, I mean we can't get into the all those things. Yeah. Yes, Ravi. And also I yeah, yeah. Microservices, we will cover it later. Even I think event driven and serverless, it's no point in explaining them if you don't understand the microservices architecture fully. We can stop it here, and somewhere we can basically cover microservices one day, and after that we can go for the event driven and serverless architectures. Okay. Yeah, yeah, we have also some more. So, I mean, the basic driving force behind this evolution is basically, to improve scalability. What does scalability stands for? Scalability is basically like, yeah, I mean, yeah, it is the capacity to scale up when the request is more. Like, when you have 100 users, the present is okay. Present application runs. When you becomes 1,000 users, will it work? When you have million users, will it work? So the architecture won't work. So you have to the architecture or the application has should have the capability to serve more and more users. The architecture that you are designing, the application you are designing, or should have that option. Similarly, flexibility. What is flexibility? Whether your application, when you are designing your application, have you thought of future changes that may come? Whether your application may able to accommodate the future changes. To simple say, a banking application, when they have started, it is simple web application. And then came ATMs, then came phone banking, then came UPI. Tomorrow, something else may come. So whether whenever such things, new things come, whether the present architecture able to add that feature will work, if we can add that feature, or should you need to rewrite again from the scratch, right? That flexibility is there or not. Similarly, right, we have maintainability. What is a maintainability? Is again like whenever there is a change. Ravi, what we can call for maintainability? One the best example for maintainability of application. Imagine, yeah, 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 yeah. That's all. Any questions? Yeah, yes, yes. Let me check this once. Yeah.